co-host.
Yeah, I need a good co-host. All right, so so we're gonna talk about a couple of things, and I do want to talk about some other thing besides education. I think a lot of times people don't understand certain things. Um, Today we're gonna talk about approximation. So I would like to talk about approximation as well, but I would like to show you how I grew up with when I was, this is not even in Asia, this is in America. When I grew up here, I moved here when I was 15. The first class I attended to here was, it's called, I don't know, it's because I have a very bad grade in China. And when I moved here, my transcript shows F all the way through, and including math. So they put me in this class called applied math, and I was like, I feel like a god in there. And so it was a high school class, and they were adding like 2-digit numbers, like 2 plus 4, and like 6 plus 8. And I was like, I will finish the test in like 30 seconds. I was like, man, I'm such a genius. And I barely understand English when I moved here. So when I got here, and the teacher's like, and I would put my head down or go to sleep. So I would, and they were, and my teacher was like, no, you don't belong in this class. So he sent me to different class. So eventually I got to like algebra 1. And so algebra 1 in high school, in 9th grade. So I was still pretty low. So the algebra 1 teachers, I have to like pay attention because I actually failed algebra 1 in China, in Taiwan actually. So I'm not a communist. I actually got through algebra 1, but I had to stay awake about like 5 minutes per day. So which is the teacher still kind of get mad at me. I finished your test in like 10 minutes rather than 30 seconds. And then moving into algebra 2, and that's where I start struggling. I mean, not start, I actually have to study, you know. So eventually I got to algebra 2. Back then we have 4-function calculator. We don't have a scientific calculator like you guys have. So when we go into geometry and trig, we have to figure out what a sine of 2 degree is, sine of 3 degree is, right? But the 4-function calculator, if you realize it doesn't have a sine and cosine and tangent button, how do you find the value of sine of 3 degrees? Well, it's not really approximate, but I'll show you though. I'll show you. So this is the first thing, this is the second thing. So I'm gonna show you. The first thing I'm gonna show you is called trig degree chart, which is, yeah, I did show you last year, but a lot of people not in my class. What? I never show you this? Okay, so now I'm showing you. So this table here is basically if you want to calculate of like angle elevation or how tall the building is, and you need to find out sine of 13 degree is. So sine of 13 degree equal to 13, and you look at the sine, is equal to 0.225. And that's it. And then you use 4-function calculator to evaluate that. No, you don't have to memorize it. But my trig teacher did show me this table and asked me to memorize the first day, and we all freaking out. And no, but you don't have to memorize it. You get to have this table used to take a test. Now the weird thing is, hey, let's look at this table. There's something weird about this table. Can you tell me what's weird about this table?
Numbers.
What?
I can't see the numbers. Thank you.
What's wrong with this table?
Past 45.
It doesn't pass 45 degrees. Ah. What if my question says angle elevation of 46 degree? Oh boy, I'm screwed.
You have to approximate.
No, you don't have to approximate. Oh, 45 plus 1 degrees? No, that doesn't work. So what if today I want to find... What if we want to find sine of 46 degree? We are kind of screwed here, right? You go to 44, but is that correct? No, it's not correct. You're not going to 44, but you're going to what? No, not one either. No, you're going to 44 is correct, but it's also wrong at the same time. It's on SAT, by the way.
Oh wait, don't you switch yes, if you do the cosine sine tangent and it goes
Okay, Bennett is onto something. So Bennett says switch to cosine.
and then go back to 1. It's a circle.
No, you guys both have same explanation, but different way of talking point. Okay, so I'll illustrate to you. I'll illustrate to you. Look at this. Look at this. Sine of 30 degrees, right? This blue, right? It's also cosine of 60 degree. No, it's not double. It's 90 minus theta. So the cofunction identity. So you look up cofunction identity. Cofunction identity. Remember, this is on your SAT now. Cofunction identity is right here. Is sine of pi over 2 minus theta equal to cosine theta or 90 degrees. They have 90 degrees right here. Do you see that? 90 minus theta equal to cosine theta. I'll write it down for you. Don't worry. I'll write down for you. You can type it. You can use your calculator right now. You can say, oh, okay, well, hey, sine of some type of angle, right, is equal to cosine of 90 minus the angle. By the way, this is on your SAT. Nearly, is this on SAT? Yeah, they. Amen.
No, it's once I take the SAT, I just forget.
That's good. Anybody remember there's a question like this? There is. There's on all the practice exam. There is one. So this is one of the thing. So approximation is hard. Shh. Approximation is hard because they built this. They calculate all this table for you a long time ago. They calculate this table a long time ago for you, right? This table, they calculate every single value by hand, and they put it on the table. They put it on the Excel sheet so you can use it all the time. Now, how did 1940? How does engineer do it in 1940? They don't have a calculator at 1940, and they probably have this chart, but they want to be even easier. How do you do it? 1940. Does anybody parents or engineers? Raise your hand. No parents or engineers? Wow, that's wild. You are? Your grandfather. Oh, that would be a good person to ask. Call him up right now. Huh?
He's not good.
No, call him up right now.
He's in Jamaica. Ask him if he's good.
Jamaica?
Yeah.
What do they use before calculator?
He's really good at math, so he just he was teaching me a little bit of calculus. Like he just.
What did he use before calculator? How to engineer? What is that stick called? What is that stick called? What is that stick called? What is that stick called?
It's like six, and then you count. I thought little tiny games on Instagram Reels like a year ago. What did he calculate?
Oh, the little the little bead.
No, not B. That's called abacus, by the way. No, it's not abacus. It's not abacus.
How many times?
All right. So you guys this is what I call.
Slide ruler. He said slide ruler.
Oh, did he say that?
Yeah. I said hi. What did you use before calculators? He said he said slide ruler. I don't. Oh my
That seems
math teacher was
correct.
asking.
I wish you just said something you just like my brain.
Oh my god.
So I'll show you how slide ruler works.
Squaring and cubing is pretty simple as well. All you have to do is you don't have to slide the thing at all. You set
You can do
the number you want
multiplication,
to square
division.
on the bottom scale. So I set the 3. Let's move this scale out of the way completely. I can actually take this out completely. Okay. So I want to square 3. Right? So I take 3 and I read the answer 9 off of the A scale. So we're on the D scale, we read off the A scale. Say I want to take the square root. If you want to take the square root of a number with an odd number of digits, then you use the left side of the A scale. But if you want a square root number that has an even number of digits, you use the right side of the A scale. So say, for example, I want to take the square root of 16. Take the square, I put the cursor at 16, and I read the answer 4 off the D scale. If I want to square root the number 256, I would have to put this cursor at 256 here.
Or odd
And read the
digits.
answer.
So 3 digits.
And 250, 252.56. That would be about there. Then I read the answer 16, or it says here 1.6 times 10 to the first, off the D scale. Cube rooting is similar, except the rules for digits, since it's, as you can see, there's 3 divisions. We have the first division, second division, and the third division over here. So cube rooting is pretty similar, and cubing is identical. Let's put this back in. Okay. On the back side, we have trigonometric functions. I'll cover those in a separate video later on.
So it turned out a slide ruler you can use to calculate logarithm, sine, cosine, tangent. You can figure out multiplication, addition, subtractions. The ruler is calibrated in such a way, it's such accuracy that you can use to calculate a lot of different things. So back then, thank you for Gabby, ask your grandparents. So it was kind of out of.
Well, he said got his first calculator in 1974. He used a slide rule.
That's crazy. Okay, so yeah, thank you for asking them that. But that's actually interesting because nobody knew about slide ruler. Most of you guys probably. I even asked the teacher across the street, and they don't even know what a slide ruler is. So, so this morning, Christy Gorber and there was 2 other people walk in. I was like, well, great. Since there's older generations here, we can ask you about this question. What do you use before calculator? And I just realized like 20 minutes later, I was like, I calling them old. Because I have no filter when I think about things.
What about?
Huh?
They didn't use slide rulers to put a man on the moon, though, did they? When was that?
Well, they did because the IBM computer is not introduced. Do you remember watching the movie Hidden Figure? Yeah. It's halfway throughout the movie. Before that, they still calculate things by hand, but they realized IBM they find the first calculator, which is as big as this 2 room add together, and they can calculate stuff. They can spell out number, but it's just as well as like a scientific calculator. So back then, 2 room worth of calculator is worth just as big today on a scientific calculator. So before scientific calculator, before 4 function calculator, it's gonna be used slide rule. So you got to interest about actual things, like what the actual thing is going to be. So today I want to talk about certain things. I want to say, hey, I have this function here, and I say, this function is going to be y equal to y1 plus sine of x. We're going to say instead of, I'm also going to say f of x. Okay, so our goal today is to figure out what is 0.1. That means 1 plus sine of 0.1. Obviously, pretend that we are 1940s. We don't have a calculator. And pretend that we are in Isaac Newton's age, which is 1600s. How do they calculate sine of 0.1? How do they calculate sine of 0.1? So in 1600s, let me talk. In 1600, people already can calculate the sine of 0.1 to 4 to 5 decimal places within seconds. I'm gonna prove to you it's working. It's called tangent line approximation. So imagine I have a graph here. If I have a graph here, and we can try to graph this. So we can try to graph this, like something like this. This is sine graph of shifting 1 plus over. And there is an equation tangent line. There's an equation tangent line here. That's not equation tangent line, like this. Okay. Now the graph I have is wrong slope, but don't worry about that. So there's an equation tangent line. So this is called equation tangent line. So what if it's 0.1? 0.1 something like right here, right? Assume that this is 0.1 here, is right here. So we want to calculate this value. But we find out tangent line is very, very close to the actual graph. Longest the x only deviate by slightly. So what we're going to do is says, okay, well, we can use tangent line approximation. Let's find the tangent line. And tangent line is 0, 1. So I'm going to take a derivative here. So it's going to be cosine of x. And luckily it's 0 because we know what cosine of 0 is. What's cosine of 0? 1. So y equal to, we're going to use tangent line approximation. Y equal to 1 minus 1 equal to 1 times x minus 0. And that's y equal to x plus 1. Is that okay?
Why did you choose 0, 1?
Because at 0, this is the x value. I'm using this point to draw the equation tangent line. And 0, 1 is where the actual value in the graph. Now I can approximate this by plugging 0.1. So use that tangent line to approximation, just plug in 0.1 plus 1, so it'll be 1.1. We find our approximation. So what we're going to do is we're going to compare to the actual graphing calculator. If I plug in 0.1 here, do you see the value is 1.0998? And look at the bottom, it's 1.1. How much deviation that is? How much deviation? Zero point 0.00017. 3 zeros. So it's a very accurate calculation, even to 3 decimal places. Let's look at 0.2. Look at 0.2. It's 1.2 and is 1.198. So it's 0.0015 roughly. It's still pretty good calculation. It's not great because you look at here. This is how much a difference between 2. Do you see that? So tangent line approximation, if you approximate a known value, a little bit distance away from the known value, you actually can get pretty accurate. Yes.
Isn't it like pretty bad, like at like 2?
Yeah, it's pretty bad too. So it gets further worse when it's going far away, right? But let's imagine that's 2. It's at 2, then it's bad because that's 1 is 3, 1 is but at 1, it's actually still fairly close. But long as anything like with a small microscope like value, like 0.1, you're gonna get to 1 to the 10,000th or 1 to the 1,000th. Yes.
This way only works accurately if it's a small number, not if it's a big.
Small number away from the known value. So I'm trying to say is this. That's today. Let's calculate 16.2. Which value do I know? Square root of 16 is what? 4. Okay, can you guys give me a value you think that's what square root of 16.2 is? Raise your hand if you think you got a value. Or I'm gonna call on you. Okay, Balin? 4.158. Okay, anybody else? 4.41. Okay. Gabby, what do you think? 4.2. Okay. Liam, what do you think? 4.2-ish. Okay. Kaden? How about Eli? What do you think? 4.0 what? Give me another number. 4.04. Okay. Armin? 4.14. Okay. Brandon? Huh? 4.12. Okay. Nelly? 4.000. Okay. Bennett?
Yeah, like 4.0. Yeah, plus like maybe that's 4.106.
4.06? Neither?
Oh, 4.106.
4.106. That's a very specific. Okay. All right. So let's see what we can find out using this. Yes, Kaden?
4.043.
4.043. Okay. You all know my guesses? So second period, I guess 4.03. I don't know if it's right, but we will see that later. So this is a yes guess. Then also you guys remember your guess. But I would say 4.03. I don't know. I didn't use a calculator. So at second period, I say it's roughly. I think it's 4.03. I don't know if it's right. So now which function I would use to take a derivative of? Which function? Like the function that we have earlier is 1 plus sine of x. What do you think the function here? Square root of x. Good. So what we're going to do is we're going to take a differential rather than derivative. The way to take a differential is very easy. It's like implicit derivative, but it's not taking derivative with respect to anything. So then what I'm going to do is I'm just kind of like d to the both sides. So if I d to both sides, that's going to give you dy. And this is going to be 1/2 x to the negative 1/2 dx. I'm not taking derivative to respect to anything. It's called differential. Then, if you really pay attention, if I divide by both sides by dx, what am I going to get? dy dx, which is normally. But here we take a differential, we just take a derivative with respect to that current variable. So y is going to be dy, x is going to be dx. Is that okay? Now, there is a difference between delta y versus dy. Delta y is the actual change. This one is the approximate change. So you say, okay, well, we're trying to calculate square root of 16.2. Obviously, we're gonna base on 16 because we know 16. So we're gonna say dy is equal to 1/2, and be 16 to the negative 1/2. Now what's dx? Dx is small changing of x. What's dx here? What is it? 0.2. Is that okay? And then that's equal to 1/2 times 1 over root 16 times 2 over 10. 2 over 10 is 0.2. So that way I can simplify the fraction. So it'll be 1 over 2 times 1 over 4 times 2 over 10. This 2 cancel out, so that's 1 over 40. 1 over 40 is 0.025. Obviously, the answer is not 0.025, but it's from 16. So it'll be 4 plus 0.025. So it's equal to 4.025, which is that it's the approximation. Let's see how accurate is this. Calculation. Square root of 16 is 4.024922. 4.024922. It's 0.0001 away. To the 3 decimal places with the calculus approximation. It's pretty damn close. Yes. Dx is the changing of x. So how much is changing from the things from 16 to 16.2? Yeah. It's like this called differential. So what happened in here? Can I figure out now dx can be negative value as well? So today your work is have to find out what is 7.9. What's cube root of 7.9? Armin, what are you doing in January 25? Do you have a speech competition that day? Check for me. Eli, would you be thinking about math competition? Huh? Do you think you can do it? I think you'll be good at it. Do you do Science Olympia or no? You do theater, right? I think you'll be good at it. So January 25th and February 15th. You gotta do it. Don't just I see. Are you sure?
Yeah, because I mean, I have the rest of the year for debate. Yeah, it's not being so I'll do the beginning and the beginning. It's today, right?
Yeah.
It changes every year. Not like this.